Alright, Common Core Algebra 2. So here we are for 6.2 Part 2 now. It's going to be kind of an extension of Part 1, obviously. And it's going to be mostly about working with radicals. And we're going to go back to roots and the index things. And don't forget about your rational exponents that we talked about in 6.1. And then finally, in Part 1, we're going to work pretty much with only numbers like we did, or in Objective 1, only numbers like we did in Part 1. In Part 2, now we're going to start to add in some of our variables, okay, or in Objective 2. Alright, so first thing, when we are combining radicals, you just want to combine them as if the radicals were variables. So what I mean by that is if I said something like 2x plus 4x, okay, we're combining addition or subtraction, that would just give us 6x. So we combined our coefficients, but we didn't change our x or the degree or the exponent of x either. And again, they must be like terms. For example, we couldn't say 2x plus 3y because our variables are different and those are not like terms, so we couldn't do anything. Okay, changing that to radicals, that would mean like a square root of 5 could only combine with another square root of 5, but a square root of 3 cannot combine with a square root of 2 because those would not be considered like terms, like variables. That's like an x and a y variable. Okay, so to show you a couple examples of that, got an addition example and a subtraction example. So here you'll notice already that we have the same thing under our two radicals. So what we're going to do, and remember, just like if it was a variable, there's an imaginary 1 here in front, we're just going to combine those two coefficients and not change anything under the radical. So 8 times the 4th root of 10. That's how we'd say this. 8 times the 4th root of 10. Okay, now on the next one you'll notice that they are not the same value under our third root. Now you need to be careful. That does not always necessarily mean that you can't simplify them. You have to try to toy with one of these to see if you can create the same value under the root, kind of like we were doing in class the other day. So the cube root of 54, I can rewrite that as the cube root of 27 and the cube root of 2. So you'll notice now this is the same as our other cube root, and this is also a perfect cube, okay, which is important. If it's not a perfect cube, or if this is a 4th degree perfect fourth or a perfect square, any of those, then we're not really going to do this because it doesn't help us simplify it all. So the cube root of 27, remember, will become 3. So we actually have 3 cube root of 2 minus, and don't forget there's an imaginary 1 in front of that, minus 1 cube root of 2. So those would simplify to give us 2 cube root of 2. So that does actually simplify. So make sure sometimes you check to make sure that you can't simplify one to actually look like the other. And then finally, Objective 2, if we talk about working with variables. Same idea as simplifying radicals, but we need to remember 3 things. That rules of exponents still exist here. Rules of radicals exist. So the exponents, that was like your MADS PM stuff, okay, that we talked a little bit about the other day. And then the rules of radicals, there was 2. There was your product property and your quotient property, which remember just meant you could separate the 2 as long as you kept them both under the root, and separate the 2 in division as long as you kept them both under the root. And in addition to that, like when we start to add in variables, this is the new piece. Think about dividing your powers by the index. Okay, so powers by the index, and you're going to need to remember remainders. These are going to stay under, I should say under, not in, under the root, okay, under the root there. Alright, so what I mean by that is if I look at the cube root of 64 times y to the 6, so I've got this whole thing that I'm taking the cube root of. But I could do my product rule and say the cube root of 64 times the cube root of y to the 6th. Okay, and there's a couple different ways we could go about this. Well, the cube root of 64 is just going to give us 4, and then here's where I was talking about you can divide your power, which is 6, by your index, which is 3. And if we divide 6 by 3, we just get 2. There is no remainder, so we don't have to worry about it. That would just give us y squared, or 4y squared. Okay, the other way to look at this is we could also say y to the 6 is like the cube root of y cubed times the cube root of y cubed. Okay, so I just split those into 2, and anytime you take the cube root of a q, it just simplifies out to y, and it simplifies out to y here, and putting those back together would give us our y squared. Okay, that's a little longer. Sometimes it works a little bit better when we don't have like a nice even number here. For example, if I said the cube root of x to the 8th. Well, I like to think of that as division. So 8 divided by 3, I know that it goes in twice. So I end up with x squared outside, but I still have 2 left over, which means I still have to have the cube root of x squared inside. Okay, so we'll go over that in more detail again in class, but that is the basic of your lesson. Big thing, combining radicals, treat them like variables, and remember they have to be like terms. Sometimes you have to simplify one of the radicals so that they are and do look like the same value under your root. And then working with variables, one good way to simplify your variables is just think powers divided by index, and remember your remainder. Alright, we'll see you next time, guys.